Hey guys, so let us continue our code about AVL trees. Okay, so in the last video we created violation handler and calculate height and violation fix. Right. So before making the violation fix method, let us create a balance factor method. Okay. It's going to take a node. Now the balance factor. So let me write some heading. Uh, the difference between the left child's height and the right child's height. Okay. Now, if not node, it means when the node is none, return 0. Return, else we are going to return self dot calculate height node dot left minus self dot calculate height node dot right. So this is how we are returning the difference between the left subtree height and right subtree's height. Okay, we are going to need this balance factor. Now, before uh, before defining our violation fix method, I would like to create these two methods: rotation, rotate left node, pass, and rotate right node. Okay. Again, we are going to pass it. Okay, and let us just create traverse method. If node if self dot root, that is how we are going to traverse throughout our data structure. So if self dot root, we are going to return in order. So in order is another method which we are going to create, and we are going to pass self dot root as an argument. Now define in order. So we are going with the in order traversal, right? So in order means left, then parent, then right. Right. So if node dot left self dot uh, in order node dot left print the node's data. If node dot right self dot in order node dot right. So that is how we traverse through our uh, data structure, right? So if you want to go for the pre-order or post-order, you are going to change the sequence of these lines in your code. Okay, so as you know that recursion works according to the stack memory. So first it will, the last most call will be the left, will be printing the last most nodes data, and when that call is performed completely, it will go back, it will trace back to the last calling place, and the last calling place will be the parent's place. So that is how the code is going to print the parent node, and then it is going to check the right node. So that is how we do this. That is how we perform this in order traversal. Okay. Okay. So violation fix. Now we talked about uh, various conditions that the balance factor must not exceed 1. Okay. So for the left heavy situation, the balance factor will be greater than 1. For the right heavy situation, the balance factor will be smaller than 1, because obviously if you are subtracting a bigger value from a smaller value, the result will be a negative, right? So similarly, if self dot balance factor of the node is okay, so we are performing this for the left situation, left heavy situation. Okay, so the left should be greater than 1. Now inside this if statement, you can check for the left right heavy situation. Okay, so you have to just check the same thing, self dot balance factor, this time for node dot left, right? Because if it is a left heavy situation, as you can see, this is the left heavy situation. Now we have to check for the left right situation, right? Okay, so for the left right situation, the left node should be right heavy. Okay, so this is what we are going to implement here. So if for the right situation, we are going to check it with 0, because technically you should have checked for -1, but when I was playing with this code, -1 gave me an infinite loop. Alright, so I decided to check it with 0, because obviously if it's -1, then it is smaller than 0, right? So if the left node is right heavy, then you have to rotate the left node to the left, right? So this is what we are doing. We are rotating the left node, this is 2, to the left, right? So the tree becomes like this, and now we have to rotate the node 1 to the right. So finally, what we are going to do is self dot rotate right, and we are going to pass the node. Now again, for the second half, this is right heavy situation. So if self dot balance factor of the node is smaller than -1, now again for the right left heavy situation, so this is right left heavy. So if self dot balance factor node dot right, now the balance, if the balance factor of nodes right, this is the right left heavy situation, as you all can see. So 1 has the right node 2. Okay, and in this situation 2 is left heavy, as you can see. 2 has the subtree left, which is the dominant one, right? So we have to rotate the 2 to the right, so we have to rotate the node to the right. So self dot rotate right node dot right. So again, I have included the this 0 so that we avoid the infinite loop. Right. And finally, self dot rotate left, and we are going to rotate the node to the left. As you all can see that we have rotated one to the left. Okay, right. So I think we are done with this violation fix method. In the next video, we are going to create the final methods, which are going to be the rotate left and rotate right methods. So see you there.